Solve y double dash plus 4y equal to 8x square using the method of undetermined coefficients. So we are given a differential equation y double dash plus 4y equal to 8x square, right? We can write this as d square y by dx square plus 4y equal to 8x square, or d square y plus 4y equal to 8x square, or just take y common from these two terms. We'll get d square plus 4 into y equal to 8x square, right? So now we'll use this also. We'll use the same equation in operator form also. Coming to the problem. Given y double dash plus 4y equal to 8x square, consider as equation 1, and we can also write this as d square plus 4 into y equal to 8x square, okay, which is in operator form, say f of d into y equal to some function of x. Where f of d equal to d square plus 4 and q of x equal to 8x square, right? Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp, where yc is a complementary function. We'll find this using auxiliary equation. Yp is a particular integral. We'll see that later. Okay, fine. Now let's find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 4, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square plus 4, and the auxiliary equation becomes m square plus 4 equal to 0. Now we need to find roots to this equation. We'll write it as m equal to minus 4, then m equal to plus or minus square root of minus 4, which gives us plus or minus square root of, we can write minus 4 as minus 1 into 4, right? Now split the square root as square root of minus 1 into square root of 4, since square root of minus 1 equal to I, right? So we'll replace it by I, and we know that square root of 4 is 2, so we'll get plus or minus 2i, right? We know that, so we got a pair of complex conjugate roots, right? We know that when m equal to a plus or minus ib, yc will be e power ax into c1, some constant into cos bx plus another constant into sin bx, right? In case of a 0, we'll get e power 0 into x, which is e power 0, so we'll get e power 0 times, right? Since we know that e power 0 equal to 1, so you'll get 1 into c1 cos bx plus c2 sin bx, which gives us yc equal to c1 cos bx plus c2 sin bx for m equal to plus or minus ib, right? Now compare plus or minus 2i or plus or minus i2 with plus or minus ib, then for b equal to 2, we'll get the complementary function to our problem. Yc equal to c1 cos 2x plus c2 sin 2x, right? We got yc, now we need to find yp. Yc equal to c1 cos 2x and c2 sin 2x. We have q of x equal to 8x square. Now compare the terms of yc with q of x. In yc you have cos 2x, sin 2x. We'll just compare the functions of x now, okay? Cos 2x, sin 2x, forget about the coefficients. or the constants C1 and C2 here, and 8. You have cos 2x, sin 2x and x square, right? We don't have any common terms. Therefore, q of x has no common term with yc, right? Therefore, yp must be the linear combination of q of x and all its linearly independent derivatives. Okay, so firstly we'll see the formula. When q of x is x square, then yp will be ax square plus bx plus c. Simply this is the formula. When q of x is x cube, then ax cube plus bx square plus cx plus d is the formula, right? Now, suppose if we have no idea about the formula, then how to find yp? Okay, we'll use trial method in order to find yp. As I said, yp must contain the linear combination of q of x and all its linearly independent derivatives. We have the terms of q of x, right? And yp must contain the term of q of x and all its derivatives. That is the formula. Okay, we'll see that using trial method. Here the required formula is ax square plus bx plus c, because we have q of x equal to x square, right? Fine. Now forget about the formula. We have only q of x with us, which is 8x square, right? And we know that yp should contain q of x and all its linearly independent derivatives, right? When yp equal to, yp should contain q of x, right? Q of x has 8x square, right? Find its derivative. 8 into derivative of x square is 2x. So you'll get something 16x, right? And again, find its derivative. Derivative of 16x is 16. So you have 8x square, 16x and a constant, right? Consider this 16 as a constant. So now write q of x and all its derivatives in a set form or a family of set form. Okay, so I'll take x square from q of x, this x square, and this x, and a constant. Instead of 16 we'll take constant. Just neglect the coefficients 8, 16, 16, just neglect it. Okay, and write x square, x and constant instead of this 16. So you have x square, x and constant. Now using this we'll write our yp. Yp equal to x square with a constant quotient or an undetermined quotient, say a, plus x with its undetermined quotient, say b, plus for constant undetermined quotient c. So this is the formula. Now we need to find a, b and c, right? So we have chosen a formula yp such that it satisfies the given equation. So the given equation can be written in terms of yp, right? Since it satisfies equation 1, we have chosen such yp, it satisfies equation 1, right? Or in other words, we'll choose a yp such that it satisfies the given equation. Okay, so we can write the given equation in terms of yp, so that you'll get yp double dash plus 4yp equal to 8x square. We have yp, but we need to find yp double dash. In order to find yp double dash, we need to find yp dash also. Fine. Now let's find yp dash and yp double dash using this yp. Let yp equal to ax square plus bx plus c. Fine. Now I'm going to find yp dash. Yp dash equal to a into derivative of x square 2x plus b into derivative of x is 1 plus derivative of a constant with respect to x is 0. You'll get 2ax plus b, right? Now let's find yp double dash, which gives us 2a into derivative of x with respect to x is 1 plus derivative of a constant is 0, which gives us 2a. We have yp dash and yp double dash. Let's now substitute in 1. We can write 1 as yp double dash plus 4yp equal to 8x square. We need to substitute yp double dash and yp in it. We have yp 2a plus 4 into, yp double dash is 2a and yp is 4 times, 4 into yp, ax square plus bx plus c equal to 8x square. This gives us 2a plus 4x square plus 4bx plus 4c equal to 8x square. Right? Now let's write this equation as 4a into x square plus 4b terms involving x plus constants 2a plus 4c equal to 8x square. Right? Now let's equate the coefficients of like terms. In order to find the values of unknowns, we are equating the coefficients of like terms. I'll begin with x square. Equating the coefficients of x square, you'll get 4a equal to 8. From this we'll get a equal to 8 by 4, which gives us a equal to 2. Now equate the coefficients of x. 4b equal to, we don't have any term, x term in RHS, so we'll take it as 0. We'll get b equal to 0. Now comparing the coefficients, constants. 2a plus 4c, we don't have any constant in RHS part, so take it as 0. Now here you're having a, substitute the value of a, which is 2. 4 plus 4c equal to 0. You can write this as 4c equal to minus 4. Then you get c equal to minus 4 by 4, which is equal to minus 1. Right? Therefore a equal to 2, b equal to 0 and c equal to minus 1. Let's substitute these values in yp. We have yp equal to ax square plus bx plus c. Now substitute the values of a, b and c here. You'll get 2x square plus b 0 into x plus c minus 1, which gives us 2x square minus 1. Therefore yp equal to 2x square. We also have yc. Let's now find the general solution. Therefore the general solution is given by y equal to yc plus yp, then y equal to yc c1 cos 2x plus c2 sin 2x, yp 2x square minus 1, which is the required solution. We can verify yp using yp equal to 1 by f of d into q of x. Okay,